Hello everyone, welcome back to my YouTube channel. As you all know, I am Bhumika, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Computer Science and Engineering. Today's subject is mathematics. Today I am going to explain the topic of application of partial derivatives. First of all, what is partial derivatives? Partial derivatives are a way to measure how a function changes with respect to one of its variables while keeping the other variable constant. It is denoted by symbols like dou f by dou x, representing the rate of change of the function f with respect to the variable x. This concept is particularly useful in multivariable calculus when dealing with functions that depend on more than one variable. Application of partial derivatives. Partial derivatives are application in real life like physics, economics, biology, engineering, finance and computer graphics. Introduction to application of partial derivatives. Partial derivatives, a fundamental concept in calculus, find widespread application in diverse fields, providing a powerful tool for analyzing the behavior of functions with multiple variables. In this comprehensive discussion, we will delve into myriad real life applications of partial derivatives spanning physics, economics, engineering, finance, biology, computer graphics, and beyond. First is physics. In the realm of physics, partial derivatives plays a pivotal role in understanding and quantifying changes in physical quantities concerning multiple variables. For instance, consider heat conduction in a material. The partial derivative of temperature with respect to spatial coordinates helps describe how temperature varies throughout the material. This insight is crucial in designing efficient heat dissipation systems and optimizing thermal properties in various applications. Furthermore, in fluid dynamics, partial derivatives help model the behavior of fluid in motion. The rate of change of velocity with respect to spatial coordinates yields more important information about fluid flow, facilitating the design of aerodynamic structures, predicting weather patterns, and optimizing transportation systems. Economics. In the field of economics, partial derivatives are instrumental in analyzing the modeling economic systems. Consider a production function that depends on multiple variables such as labor and capital. The partial derivatives of the production function with respect to each input variable provide valuable insight into the marginal productivity of factors of production. This information is crucial for business and policymakers in optimizing resource allocation, determining optimal production levels, and understanding the impact of changes in input quantities on output. Additionally, in the microeconomics, partial derivatives are utilized in utility theory. The partial derivative of a utility function with respect to a particular commodity measures the marginal utility of that commodity, informing decisions about consumer preferences, budget allocation, and market equilibrium. Engineering. Engineers extensively apply partial derivatives in various disciplines to analyze and optimize systems. In structural engineering, for example, the partial derivatives of stress and strain with respect to spatial coordinates are used to understand the distribution of forces within a structure. This information is crucial for designing safe and efficient buildings, bridges, and other infrastructure. In electrical engineering, partial derivatives help model and analyze the behavior of circuits. For instance, when studying the transient response of an electrical circuit to changing input, partial derivatives aid in understanding how voltage and current change with respect to time. In the biological sciences, partial derivatives are applied to study complex systems and processes. Enzyme kinetics, for example, involves modeling the rate of enzymatic reactions as a function of substance construction. Partial derivatives are employed to understand how changes in substrate concentration affect reaction rates, providing essential insights into mechanisms of biochemical reactions. Population dynamics in ecology is another area where partial derivatives find application. The partial derivatives of population growth models with respect to variables such as birth rates, death rates, and resource availability help ecologists understand the factors influencing changes in population size over time. Computer graphics. In the field of computer graphics, partial derivatives play a crucial role in rendering realistic images, shading models, which determine how light interacts with surfaces, often involve calculating guidelines using partial derivatives. This information is essential for creating visually appealing and lifelike images of computer generated environments. Texture mapping in computer graphics is another application where partial derivatives are employed. By calculating partial derivatives of texture coordinates with respect to screen coordinates, graphics algorithms can map texture on three-dimensional surfaces accurately, enhancing the realism of virtual scenes. Geophysics. Partial derivatives are extensively used in geophysics to analyze seismic data and model subsurface structures. When interpreting seismic waves, the partial derivatives of wave velocity with respect to spatial coordinates help geophysics characterize the composition and geometry of geological formations beneath the Earth's surface. This information is vital for applications such as oil exploration and earthquake hazard assessment. Medicine. In medical research, partial derivatives are applied in pharmacokinetics to study how drugs are absorbed, distributed, metabolized, and excreted in human body. Understanding the partial derivatives of drug concentration with respect to time and physiological variables is crucial for optimizing drug doses, remains, and predicting therapeutic outcomes. In conclusion, partial derivatives are a versatile and indispensable tool with applications spanning a multitude of disciplines, from physics to finance, engineering to biology, and beyond. The ability to analyze and quantity changes in functions with respect to multiple variables has revolutionized our understanding of complex systems. As technology advances and interdisciplinary research flourishes, the applications of partial derivatives continue to evolve, shaping the way we approach and solve real problems. This exploration provides a glimpse into vast landscape of possibilities that arise from the elegant and powerful concept of partial derivatives. Thank you for watching my video. Please do like and subscribe and do not forget to share.